Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have k to the power of 6 is equals to 7 to the power of 6, and we solve this problem for all the values of k. So first we rewrite this equation as in this form. So here we move the 7 to the power of 6 into the left hand side, and it will becomes k to the power of 6 minus 7 to the power of 6, and this whole equation is equals to 0. And this equation is implies that here we rewrite this equation as we write k to the power of 6 as k cubed and its whole square, minus we write 7 to the power of 6 as 7 cubed and its whole square, and this whole equation is equals to 0. And now here in the next step we need more simplifications, and it will be written as, here we need to make the factors of this equation by using this formula. If we have a square minus b square equals to a minus b times of a plus b. So according to this formula we write our above equation as in this form. So this will becomes here k cubed minus 7 cubed into k cubed plus 7 cubed, and this whole equation is equals to 0. And now we divide this equation into the two cases. The first case is we write k cubed minus 7 cubed equals to 0. We call this is equation number 1. And the second case is k cubed plus 7 cubed equals to 0, and we call this is equation number 2. So here we need to solve both of these two equations, and we easily get the values of k. So here in equation number 1 we use this nice formula. If we have x cubed minus y cubed, it is equals to x minus y times of x square plus xy plus y square. So in equation number 1 we apply this cubic formula. So after applying this formula, our equation number 1 is implies that, so first you have x minus y, the value of x is k minus y is 7 into x square. So x is k square plus k into 7 plus 7 square, and this whole equation is equals to 0. And in the next step we divide this equation into the two cases. The first case is we write k minus 7 equals to 0, and the second case is we write k square plus 7k plus 49 is equals to 0. So from here we easily get the first value of k, and that is k equals to 7. And from here we need to find the other roots of the given equation, so that here we use the quadratic formula to solve this equation. So we write its coefficients are a equals to 1, b equals to 7, and c equals to 49. And we state the quadratic formula as k equals to minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. And we state the quadratic formula as k is equals to here we need to substitute all the values of a, b and c in this formula. So when you put these values here, it will becomes minus 7 plus minus square root of b squares. The value of b is 7, and it will becomes 49 minus 4 times of a is 1 and c is 49, and it is divided by 2 times of a, and here our a is equals to 1. So in the next step we need little bit more simplifications, and here you see that inside the square root we have 49 be the common term, so that we will be take common 49 from here. After taking common 49 we get the remaining values are 1 minus 4, and it is divided by 2. So from here we get the values of k is equals to minus 7 plus minus, we know that the square root of 49 becomes 7, and here we get the remaining values are 1 minus 4, and 1 minus 4 becomes minus 3, and you know that here we get square root of minus 3, and we know about that the square root of negative term becomes iota, so we get here square root of 3 into iota, and it is divided by 2. So these are the other two complex roots of the given equation which we get here from equation number 1. So here we need to focus on equation number 2. So that our equation number 2 is implies that, so in equation number 2 we use this nice formula, and if we have x cubed plus y cubed is equals to x plus y times of x square plus xy x square minus xy plus y square. So after applying this cubic formula in equation number 2, so it will be written as, so we have k plus 7 times of so it will be written as k plus 7 times of k square minus k times of 7 plus 7 square, and this whole equation is equals to 0. And now in the next step we need more simplifications, and it will becomes here k plus 7 times of k square minus 7k plus 49, and this whole equation is equals to 0. And now in the next step we need more simplifications, and it will be written as, so we have here we divide this into the two cases. The first case is we write k plus 7 equals to 0, and the second case is we write k square minus 7k plus 49 is equals to 0. So here we again solve this case and we get the other values of k. So from here we get the value of k is equals to minus 7, and from here in order to find the values of k we need to use the quadratic formula. And first we write the coefficients of this equation, and its coefficients are a equals to 1, b equals to minus 7, and c is equals to 49. And we state the quadratic formula as k is equals to minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. So here we substitute all the values of a, b and c here, and it will becomes, when you put this value of b here, it will be written as 7 plus minus square root of b square. So b is minus 7, and minus 7 square becomes 49, and minus 4 times of a is 1, and c is 49, and it is divided by 2 times of a, and here our a is equals to 1. So here we need little bit more simplifications, and it will becomes here 7 plus minus, when we take common 49 inside the square root sign, it will becomes here 7 times of 1 minus 4, and it is divided by 2. So here we obtain this is 7 plus minus 7 times of, here we know that 1 minus 4 becomes minus 3, and square root of minus 3 becomes here 3 times of iota, and it is divided by 2. So finally we have the other roots of the given equation are 7 plus minus 7 times of square root of 3 iota, and it is divided by 2. These are the other complex roots of the given equation which we get here from second case. So this is the final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.